Hello, this is Joshua Kraus. I'm going to do a quick review and tutorial for using the PhET Gravity and Orbit simulation, which has recently been upgraded to HTML5, which will make it useful for hopefully a number of years to come. Clicking on it, the PhET Gravity simulation is a great way for students to begin understanding NGSS HSPS 2.4 and HSESS 1.4, which address Newton's and Kepler's laws describing gravity and orbits, respectively. You get two choices when opening it up. You have model and to scale. We'll start in the to model version. We'll come back to the to scale. You can see over here on the right side, they've given you a number of choices. There's plenty of options to play with, but this simulation is constrained, so the kids can't do crazy things that will cause problems. Well, too many problems. But they have an opportunity to explore and manipulate a number of variables and learn an awful lot about orbits and gravity. My suggestion is to begin working with the simulation with the path and grid buttons open. Checking these give you a nice grid layout, and you can watch as Earth moves along the path it follows. Since we're here, you can also click it into fast mode, which actually decreases the accuracy of the algorithm apparently, or you can go into slow mode, which actually improves the algorithm as well, but it's very slow to watch. Normal works quite well. Sometimes it's nice to go into slow mode, and something I emphasize with my students frequently when using the PhET simulations is to go into the screenshot down here. You can use the screenshot button here or the shortcut tabs on the shortcut buttons on your desktop. It is also nice to give the kids an opportunity to just play and manipulate all the different things here. It's kind of fun to watch the orbit go around, and if you pause it and clear, and then you can reset, you can move the planet in and out. Like I said, I like having the path and the grid. You can manipulate the mass of both the planet and the sun. This mode is also kind of fun because if you have path on, you can see the fun pattern that the moon makes going around the sun, around the Earth. Kids find that rather fascinating as they go through the process. With this on and the different paths, actually, we're going to pause this and then we're going to go back to just Earth and Moon, Earth and Sun here. When you hit play, it could be kind of fun, and a good suggestion to start with would be just manipulating the mass of the two different bodies here. And by manipulating it, you'll actually see the orbit change with the path on, and sometimes you'll get a crash. That crash, the kids enjoy that as well. Changing the orbit, changing the mass, and leaving the path on. What's interesting to try and get the kids to notice is that acceleration you saw right there as it's getting closer in, which will help them work towards thinking about mass and distance from masses being the two parts that make up Newton's law of gravity. So once students have had an opportunity to play for a few minutes and experiment on their own, an interesting question I've liked to ask them, I've enjoyed asking them when they've used this simulation in the past, is how does changing velocity, mass, or distance from the center large mass, the sun in this case, affect stability of orbit? They frequently like seeing what causes a planet to crash into the sun. They also like seeing what causes planets to go zipping off away from the sun. And they can do various things while playing with it. Turning these on again, you can emphasize the gravity force, which is a nice connection to really show them. And if they're paying close attention and they're changing the mass, there they go, you see the force changing. And with that force changing, you get a change in the orbit. And you get a greater change as you change the mass of the sun. If I don't bring it back, I'm going to get a collision here. But the students do enjoy seeing the planet move around, or maybe watching it fly off into space like it's about to. And they actually recently added this return objects. My bet is if we increase the mass of the sun, we can get it to come back. And there it goes. It's coming back. Let's try and avoid a collision. The students have a great deal of fun playing with this app and moving the stuff back and forth and answering that question And maybe designing an experiment around it is a great way to get them to think about the various parts of Newton's law of gravity and Kepler's laws of gravity and orbiting. And at this point, I'll switch down here to the scale model of it. And apparently I can't get, there we go. I can switch to scale. Scale adds two new features here. You have the mass, and it gives mass in terms of Earth. So one Earth mass, or 333,000 Earth masses. You also have a measuring tape. The measuring tape is in a very large distance, but it's appropriate when we're talking about gravity. Turning these on and then watching the planets sweep around, now you can really get at Kepler's laws. So you can measure out the distances at different points, and you can also use the time to start talking about Kepler's three laws. Overall, when I've used this simulation, students really enjoy playing with the various things. You can get mass, and especially if they watch the distance and how the orbit speeds up as it comes in closer, you can see the acceleration as it comes in. That acceleration is really helpful for the students to see, and that seeing that, they get the mass and the distance relationships to really derive Newton's law of gravity. Hopefully you enjoyed this little brief tutorial and it made some of this stuff more clear and gave you some ideas for using it with your students. Thank you.